Let's try to understand what is a finite state automata, or moreover deterministic finite state automata. I'm assuming that you're watching this on your mobile device or your laptop. So this is your laptop and there can be two cases exactly. Either this could be switched on or this could be switched off, obviously. So when you get your laptop for the very first time, it would actually be switched off, right? So when you first get it, it would be switched off. Now what would happen if you press the power button? So you press the power button, what would happen? Your device would switch on. And when your device is switched on and then you press the power button, what would happen? Your device would again switch off. Simple. Now let's say your device is actually switched on and you don't press the power button. What would happen in that case? Nothing would happen. You would still stay in the on state. Similarly, on the other hand, if your device is switched off and you don't press the power button, your device would still remain switched off. So if you don't press, you still stay switched off. Finally, in the end of the day, what you want is to be in this on state. So I'll mark this state with one more circle. Now with just this simple example, we can actually understand what are finite state machines. Now if you see, we have finite states in this, which means it's countable, and we have two states. Moreover, for every state, I know what would happen when you press the power button or you don't press the power button. So I can deterministically tell what would happen when you press or don't press given the state that you are in. So this system or this machine is actually deterministic as well. So it's deterministic, it's finite, and automata is another word for machine. So it's a deterministic finite state automata, DFA. Now how would you define this mathematically? So a DFA mathematically is represented by a 5 tuple. First is the Q, the set of all states. Second is the sigma, or the alphabets or the actions that you're going to take. Third is the delta. This delta is the transition function. It would tell you, given a state and the action that you take, where you would actually end up. Next is the start state. So where do you actually start? And finally, you have capital F, which is the set of all final states, where you want to actually end up. So mathematically, this is the 5 tuple that defines any DFA. And for this example that I just gave, what would be Q, sigma, delta, QS, and F? So for this Q, this would be on or off. These are the only two possible states in this deterministic finite state automata. What is sigma in this case? Sigma is either press or don't press. Now the delta, the transition function, that's interesting. So if you're in the off state and you press the button, what would happen? You would go into the on state. If you don't press the button, what would happen? You would still stay in the off state. Now let's say you are in the on state and you press the power button, you would go to the off state. And if you're in the on state and you don't press the power button, you will still stay in the on state. So this is the transition function. It would tell you, given the state, given the action, where you would end up. Now the third is the QS, the start state, where you would actually start. So in this case, you would initially be starting with an off state, because when you get your laptop, when you get your mobile phone, it would be switched off. This is the off state. And what is F? F is the set of all final states. Now in this case, there is exactly one final state, but in general you can have more than one. So since this is a set, I'll use this curly braces. So the answer is the state on. So for this given automaton, this is the mathematical definition for this.